Okay, so we are looking at fundamental counting principle, starting with the basic tree diagram to show this sample space, all the different iPad minis in this case. So, for an iPad mini, we have a choice here of black or white. Actually, I'll move this up a little bit. Okay. Then, if the color is black, we have a choice of Wi-Fi or Wi-Fi cellular. If it's white, we have that same choice. For each of these, it could be 16 gigabytes, 32, or 64. Here, 16, 32, or 64. Here, 16, 32, or 64. So you can see how it gets pretty cramped and it would be difficult to show this for every question. And we certainly wouldn't want to do that for every question. But our sample space then, this will get you all the different types of iPad minis with those options. So it could be black, Wi-Fi 16, it could be black, Wi-Fi 32, black, Wi-Fi 64. So each branch that follows through is your sample space. And here, this could be black, Wi-Fi cellular, 16. So when you do that, I'm not going to write all of them out, but you'll see how many you get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's 12 different possible iPad mini tablets. How could you get that a little bit faster? Well, there's 2 options for the color, 2 options for the model, 3 options for the memory. What can you do to 2, 2, and 3 to get 12? Multiply. So for each of these, you multiply by 2, then by 3. So 2 times 2 times 3 gives you 12. So you would not do a tree diagram from now on, unless you're asked. Okay, so the fundamental counting principle says if one item can be chosen in m ways, second item in n ways, both items can be chosen in m times n. The last one we had 3 different parts to it. So it could be m times n times t times 2, whatever, however many options for each part of it. Okay, so try that example. An upscale restaurant offers only 3 choices of appetizer, 4 main courses, 2 different desserts. If the customer chooses exactly 1 appetizer, 1 main course, and 1 dessert, how many different meals can they choose? Hands up, what would that be? Huh?
24.
24, good. Okay, so 3 appetizers times 4 main courses times 2 desserts is 24. So sometimes you might, I don't know if you've been to a restaurant where it's a set menu. They sometimes call it a prefix. No, I don't know in French, there's a version of that. So it's like a fixed menu, so you might have that case happen. So you with your family say, there's 24 different possible meals you could have. So you can impress them, right?
Like that's
Well, maybe as engineers don't do a lot of this work, so. Okay, so now we get into really common questions involve arrangements of letters. So thinking about this, you could do a tree diagram again. You're not, once you see it once, you're not going to do a tree diagram again. But basically, we want to determine the number of ways the letters can be arranged. So we have to use all the letters, unless it tells us not to. So right now, we're using all of them. So there's 4 letters, and we have to use each of them. So basically, for the first letter, maybe I'll do a tree diagram for you. So we could have M or A or T or H. Don't do this. Don't write this down. Okay? Do not write this down. If the first one's M, then you have a choice of A or T or H. What's so funny?
It's that if you're to do this for factor, it's take it so long.
Yeah. Yeah. Okay, so you're not copying this down. I'm just showing you. So that thing here would be M or T or H. So basically, for each of these 4, there's 3 here. Then so that I'll go, just go dot dot dot. Then MA, then you could have a T or an H. Here you would have an A or an H. Here you would have an A or a T. Okay, so for each of those 3, for each of those 2, and then obviously your name letter. So 4 times 3 times 2 times 1. That's what you would do. Alright? You know how to tree diagram. So that's 24. Okay? How you might show that, how I show it, kind of, it's work, but it's not really, it's not a tree diagram. In the next one, I'll do it. There's 6 letters, so I put 6 dashes down to represent the space where each of those letters is going to go. Okay? So then, if there's 6 letters, I often just write a little 6 above there and fill them up. Sometimes they're really big words. You can only use each letter once. So for your first letter, you have 6 possible letters that you can start with. Okay? Once you've written that down, whatever that is, if you're doing a tree diagram, then your next column, you would have 5 possible. Right? 1 less. This was 4, and then we had 3 each here, then 2 each here, then 1. So this would be 5. Okay, so you've got 2 letters, then you have 4, then 3, then 2, then 1. And you multiply those together. Okay. We'll learn a fast way of multiplying those in a sec. But for right now, just do it in your calculator. Obviously, by 1 doesn't change anything, so 720 ways of writing out arrangements. That's why you do not want to do it the long way. Right? You're not going to write out all the possibles because you're okay, so to make, in some cases, to make your life a little bit easier, you can use what's called factorial rotation. Okay? So, right-hand side of the page, it says, based on the answers to question 2, on the chart shown to the right, answer the following question. What function does factorial perform on the number? So take a look here. 720 was the answer to the last one. This is saying that 6 factorial, but exclamation mark is not 6. It's called 6 factorial. You get that joke? It's not an exclamation mark, it's a factorial. So, 6 factorial is 720. This was 720. This was 6 times 5 times 4 times 3 times 2 times 1. So that means 6 factorial is equal to this. Okay? So 5 factorial would be 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 1 times 2 times 1. So what function does that exclamation mark perform? We multiply a number with consecutive decreasing natural numbers. Or you can say all the natural numbers less than, right? Because the natural is going to be natural numbers. So the value of 8 factorial, well, first of all, if you did it the long way, it's going to look like that, right? So in your calculator, now saying that, I still have 6 factorial here. So if I already have 6 factorial, then I can multiply by 7, by 8, and that will be 8 factorial. Now, there is a factorial button on your calculator, or key in your calculator. So if you go math, key, so everyone press math, and then go to PRB or probability, PROB, depending on your calculator. And it's the 4th one down. Okay. So I don't want to put, I have the answer there, so that's gonna, I think that'll give me the error actually. Yeah, it's too big. So you want to put a number in, so 8, then math factorial, or math probability factorial. Okay. So try it on your calculator, make sure you know where that is. Okay, so you know how to do that? Sometimes, for numbers like 5 factorial, it's easier just to almost do it in your head or enter it 5 times 4 times 3 times 2. You probably remember it after you've done a number of questions like that. Because really, you have to go there. You have to go math to the right PRB down to or press number 4. It takes a couple of functions in your calculator to get there. Sometimes it's faster just to show the multiplication. The general case for factorial here, so if it's n factorial, then that's equal to whatever that number is to start. I want to get rid of that. I don't know. Anyway, n there, and then multiply by 1 less than that would be n minus 1. And 1 less than that is n minus 2. But you got to get down to 1. And you can't throw an infinite number in there, right? So then we use dot, dot, dot. And then maybe you go with 3 times 2 times 1. Okay? That's how you would show. Okay, so try 100 factorial over 98 factorial in your calculator, just like that. What happens? Overflow, which means it can't handle that. Okay? Not that the answer is too big, but parts of that are too big. 100 factorial it won't do. You could try just separately, 100 factorial. Oh, sorry.
52 factorial.
So it's going to, even for that, give you an error. But think about what that means. You can do this in your head. So sometimes you don't get a calculator. general calculus. Although this you won't be doing much with factorials, but 100 times 99 times 98 down to 2 times 1, let's say. Okay, over top of 98 times 97 times down to 2 times 1. Okay, all of this will divide out. What you're left with is 9,900. Okay? You use your head, not your calculator. Okay? So really, you could also show that as 100 times 99 times 98 factorial over 98 factorial. Those divide out. Okay. So factorial means every number down to 1 multiplied together. So it says write the questions in the number 2 in factorial. So here, this would be 4 factorial. This would be 6 factorial. Valeria.
I don't know if maybe we'll discuss this later, but I think you do negative factorial, for example, negative 4 factorial.
We're not going to do it.
You're not going to have negative. You can't do it here. Not even with the down function.
Yep, these are all numbers of objects. We're never going to have a negative number of objects.
Pardon?
These are all numbers of objects or letters or whatever. We're never going to have a negative number of letters. Alright, so it's always positive. Okay? Yes.
When you put it in the calculator, it just comes a negative of the factorial. For example, negative 1 factorial would just be the negative of 10 factorial.
Yeah, and you can get back into the triangle.
Yeah.
Yeah, that's not right. Okay, so this is your permutations. In general, there are n factorial ways to arrange n items. The items are different. We're going to talk about that on the next page, so hold on. Okay, so now that we know about factorials, let's do some more examples. And it says leave the answers in terms of factorials sometimes, right, rather than evaluating all of them. Okay, so first one says, in how many ways can 5 teachers and 10 students be lined up if there must be a teacher at both ends of the line? So again, how I show work is not going to do every arrangement, but I know that I have to have a teacher at the beginning. So this is my line up here. Someone's going to be here. Then a whole bunch of teachers and students and a teacher at the end. Okay? So in total, there are 15 people that have to line up. Okay, so you want to know the total. In terms of the teachers, there's 5 teachers. So there's 5 possible teachers to be in the first position. Okay? Used one of the teachers up. So now there's only 4 teachers available for the last position. Okay? It says there must start and end with a teacher. And then in between, no one cares. Okay? So that means that there are 2 teachers out of this used up, so that means there's 13 people that we need to arrange inside this. Arranging any group of people, 13 people, will be 13 factorial. Okay? So we could show this, we're not going to evaluate it, we'll just show this 5 times 4 is 20 times 13 factorial. That would be simplifying it a little bit. Okay? If you want to go back and find the actual number of them, you're welcome to do that. Okay. Next one, letters in Jasper? 1, 2, 3, 4, 5, 6. 6 letters. Start to check, are there any repeated letters? Doesn't matter today, but we will look at some where there might be repeated letters. Not today, or not in Jasper there are. So there's 6 different letters. Okay, so how many arrangements can we make using all the letters if no letters can be repeated? Okay, so there are no further restrictions. So yeah, this is just like the word math that we used on the previous. Right, so if you want to show it the long way, 3, 4, 5, 6, then it's 6 times 5 times 4 times 3 times 2 times 5. Or 6 factorial. Alright? It's just like the word math. Now the next one says it has to start with J. So 1, 2, 3, 4, 5, 6. This I probably wouldn't show that out necessarily, but this I will. The first letter has to be a J. Okay? So there's only one J to choose from. So only one option for that. And you've used the J up. So now there's only 5 letters to arrange in the remaining positions. Okay, so that's 5 factorial. So that's basically like taking, in our previous math one, it's saying this one has to start with an M, so we're only going to use this set of branches. Okay? So then there's 1 M, then 3 here, because there's 3 remaining letters, then 2, then 1. Okay? So that's taking one of those branches. Okay, so then 1, 2, 3, 4, 5, 6. P and R must be in the middle. So P and R, or could it be R and P? Yep. So in here, you might actually show this as kind of like that, just grouping them together. So there's 2 choices for that and 1 for that. Alright, so it could be PR or RP, 2 possible arrangements of those 2 letters. Doesn't matter the other one, so we've used P and R up. Okay, so we have 4 letters left to arrange in the remaining positions. So really, that's same as 4 factorial times 2 factorial. Now we're getting pretty small, right? So 4 factorial is 24 times 2 is 48, if you want to actually find the value. You don't even need a calculator. Okay? Sometimes we'll talk about consonants and vowels. Okay? So you got to know that. So here, in the word Jasper, there's 1, 2, 3, 4 consonants and 2 vowels. And it says a consonant must be on either end. So it's kind of like the teacher one back there. We have 4 consonants. So this has to be a consonant and this has to be a consonant. Okay? So we have 4 consonants to choose from. 1 goes there. Then we have 3 left to choose from to go there. Okay? It doesn't say, sometimes we'll have questions where it says exactly 1 consonant. That means you can't have a consonant there, and that's a little bit different case. We'll get into some other ones later this week. But we've used up, we've got consonants there, we've used up 2 letters, so then we have 4 left to arrange. Okay, so that's really 4 times 4 factorial times 3, so 4 times, so that's 12 times 4 factorial. Which is, you can find that, I guess, 24, 24 times 12.
4, 5, 6.
Okay. Consonants together. There's 4 of them. So what I do is I start with 4 of them being at the beginning. Okay? So let's say I'm putting all my consonants at the beginning. They have to be together. So that would be 4, 3, 2, 1, arranging the consonants. The vowels would be 2 times 1. But those consonants could be get together starting there, or they could be together in these 4, or in these 4. So it's kind of like choosing this as a group. So you kind of join up all of those, and then you're really arranging this with these other 2 letters. So this as a group and these 2 letters. So there's 3 ways of putting that together. Okay, so there, between, and at the end. So what ends up happening is that it's always going to be however many arrangements of that grouping of the consonants, and then multiplied by the factorial of the number of these groups. So here I have to multiply by 3. I'll use that for the in green, because that's not a letter. Okay, there's the 6 letters, but now this group could be here, or it could be from here to here, or it could be from here to here. There's 3 ways of putting that grouping of consonants. So that's going to be 4 factorial times 3 factorial. So 6 times 24. Okay, so that's if you're grouping things together. You find the arrangements of those objects in your group, and then how many ways you can arrange that in the whole thing. Guys, questions?
What about the 2 in like a small group?
Yeah.
So that's not a group then. They're also have to be together.
Wouldn't that like also count there?
It is there. 2 times 1 times 3 is 3 factorial. So this is the arrangements of 4 consonants. This is the arrangements of 2 vowels.
Oh,
Okay. This can be in there, or it can be between there, or at the end. So 3 ways of putting that. Okay. Ellie? Because as I said, so this is a group. It can be at the beginning. It can be between the 2 vowels, or it can be at the end. So there's 3 ways of putting that group of consonants in there. Okay, so I'll do it the long way. So here, your 2 consonants are A and E. So you could have A and E, or you can have E and A. Your group of consonants can go here. Okay, they could go in there, or they could go at the end. Right, so there's 3 ways for that. If it's E, A, they could go at the beginning, then there, or at the there. So for each of these E, A, and E's, right, there's 3 places to put it. So that's where the 3 comes from. So, very similar to that one, 1, 2, 3, 4, 5, 6, is vowels have to be together. So this was consonants together, now the vowels have to be together. So I'll group those. These are vowels. Okay, so there's 2 vowels to arrange them. It's just 2 ways, A and E or E and A. Now, then the consonants, obviously 4, 3, 2, 1. But this would be your answer if it says start with the vowels. It just says the vowels have to be together. So they could be starting there, or they could be here, or they could go be after the first consonant, or after 2 consonants, or after 3 consonants, or after 4 consonants. So 1, 2, 3, 4, 5. As I said before, this is a grouping now. So we're really arranging 5 items. One is a group of 2, but that's like 5 factorial. We're multiplying this by 5. So this is going to be 2 factorial times 5 factorial. So you arrange your vowels together, your consonants, and then how many arrangements of those are there? There's 5 ways of putting that in. Okay, so that is 5 factorial times 2. Okay, so the next one's kind of nice. If you were to actually try to do it the long way and figure out them not together, each possible case, that would take some time. But vowels not together is the opposite of vowels being together. We call it the complement. Okay, so the complement of vowels together is that they're not together, the opposite. So we can go here, the total number of arrangements minus vowels together. So the total number of arrangements was like this, 6 factorial. Vowels together was 2 factorial, 5 factorial. And that was, what was 6 factorial? That's 120 times 6 is 720. Going to go back so things are a bit bigger on this one here. Okay, so this next one, consonants are in the same order as they are in that word jasmine. So that means there has to be have a J, an S, a P, and an R. Same order. Okay? Because of that, there's only one way to have those consonants there. Okay? So we want to figure out what we're going to do with those vowels. This one you could actually do right by writing it out. Sometimes you might want to do that in this case. But think about, okay, so now I have to, let's place the A to start, for example. So placing my A, I could place it in front here, or between here, or between here, or between here. So I have 5 possible places to put the A. Okay? For each of those places, then I have to put the E. Okay? So, maybe I'll do it over here so you can see what happens. There we go. So here, A, S, P, R. So I have to put the A there, or there, or there, or there, or there. If I say put it here at the beginning, so then this would be some of my longhand work. So say I put it there, A, J, S, P, R. So then my E, I could put at the beginning there, or after it, or here, or here, or here, or here. So that's going to happen for all places I put the A. I will have 1, 2, 3, 4, 5, 6 places to put the E. Okay, notice how one of the places is you could go is at the beginning. So I don't then just start doing, okay, if I put the E to start, because this is going to cover everything. So this is for one, that's for this arrow here, is here, and I have 6 possible places to put E. Okay, so I've got 6 there. Then what if I put my A in here, at this arrow, then I have 1, 2, 3, 4, 5, 6 places to put the E. Okay, so now I've got 6 plus 6. And then if I put the A here, I'd have another 6, and so on. So for each of the 5 places to put the first letter, I have 6 places to put the next letter. So it's going to be 5 times 6. And that's it. So I put arrows there. There's no real work. You could then say between those. Okay, and even though that's pointing to these consonants, we're really thinking about how it relates to the first one that you put in there. So it's going to be 5 times 6 is 30. So if you need to do a little bit of work on your own paper to try that out, do it. Okay? So I put my arrows for where I can place the first letter. I tried that first letter to figure out that there were 6 places for the E. I erased that, then tried the second place for A. There's 6 places to put E for that one. You can erase that letter, and then put here, put the next, put the A in here, and then you'll have 6 places to put the E if it's there. So for each of these 5, there's 6 places. 5 times 6 is 30. So that one's a harder one. Spend some time, do a little bit of the long ways to get your head around that one. I guess that's not on the video. Okay, sometimes we want to come up with possible numbers, okay? So in this case, it says how many 3-digit numbers can be made if the digits can be repeated. So, a 3-digit number has 3 digits. Is this considered a 3-digit number?
No.
No. So you cannot start with 0. That's considered a 2-digit number. So I always put cannot start with 0. The questions that might have an opportunity to put a 0 there might be something that we talk about, like a lock for your locker. Maybe the first number is 0, something like that. But for a 3-digit number or any digit number, they cannot start with 0. How many digits are there?
No.
And here's some 10s and here's some 9s. Not 3. It's 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits. Okay? So, don't forget that. 10 digits. Okay? Only 9 possible digits can go in that first number because you can't start with 0. In this case, it says the digits can be repeated, right? It's not going from a given word like Jasper or mouth. Digits are digits, right? There's 10 of them. It says they can be repeated. So we can only have 9 possible for the first, but then we can have 10 and 10 possible. So 900 possible 3-digit numbers. Okay, so then cannot be repeated. So again, you can't start with 0. If you do, then it's not considered a 3-digit number. Okay, so there's 9 possible for that. You use 1 digit up out of the 10. Okay, it says it cannot be repeated. So we have 10 digits, we've used 1 up. Okay, 0 can be used in these ones, so you have 9 left for the next digit, or the next place value. Okay, now you've used 2 up, so you have 8 left. So we're not going to use factorial for this, right? Because then you'd have to divide in order to actually get a factorial. So what that 9 times 9 is 81 times 8. Okay, numbers have to be greater than 600. Okay, so obviously this can be a 6, a 7, an 8, or a 9. Can't be 0, right? But that makes sense. Maybe 0 is not a 3-digit number anyway, right? And notice how they cannot be repeated. So that's going to work out okay, because if we had a 0 here, we're not going to have a 0 here. So we'll never get 600 anyway, right? Because they cannot be repeated. So if we happen to get a 0 in the next position, the next one would have to be a non-zero, which is greater than 600. Okay, so you don't actually have to worry about that too much. That tells you this part. So there's 10 digits, but the first one has to be a 6 or 7, 8 or 9 in order to be greater than 600. So there's 4 possible digits for that. Okay, but they cannot be repeated. So 1 is used up. 1 number is used up out of the 1 digit out of the 10. So now we have 9 left and 8 left. For the remaining digits. Okay, so 3-digit number can't start with 0 and has to be odd, which means the last digit has to be an odd number. So 1, a 3, a 5, a 7, or a 9. Okay, so I start with that most specific restriction, this one here. Okay, because that doesn't have 0 in it anyway. So there's 5 possible odd numbers. Okay, you've used 1 up, and you can't start with a 0. So you've got 10 digits originally. You use 1 here, and you can't use a 0, and that's not even one of these, so it's not going to overlap. That means you have 8 possible value digits you can use for the first number. Okay? Because it can't be 0 and it can't be one of these. Now you've used 2 digits up out of the 10, so you have 8 possible for the next position. So what's that? 40 times 8 is 320.
The one greater than 600 compared to the odd one. So in order to get the 600, so the 2 values are the 2 values, and then at the end stay the same as the no 600, but then in the odd number they go up. You know what, like the original equation with no restriction, 998, and then in the one right next to it is 490, so it's in, at the end say within 24. But then this one doesn't allow the two numbers.
Well, there's this on the end, right?
Yes, that one is the thing at the beginning.
Well, this has only one restriction on it. This has two things. Right? So this, you have 5 choices and you use one of those up. So say it was ends in a 3, right? That 3 is gone, you can't use it again, and you can't use 0. So you only have 8 possible numbers you can use them. You use them up. So then you use 2 up, but the 0 goes back in, right? Like you couldn't use it there, but it's available in here. Right? So it's back to 8. Okay, what's the opposite of an odd number? Even number. So we can go total minus odd numbers. And then I'll show you another one. Yep.
Is 0 even or odd?
Well, 0 at the end is even. Yeah. If you end the number in 0, it's even.
What if it's like 0 plus 7?
Yeah, there's different meanings on that. You would say it's even. Certainly not odd. But whether it's even or odd is depends on the book you read. But it is divisible by 2, so that's really the definition of even. So. Okay, so the other way of doing this is three digits can't be 0. For a 3-digit number to be even, it could be 0, 2, 4, 6, or 8. Ending. Problem is, this can't be 0. So if you're going to look at this case where these kind of conflict with each other, you need to do 2 particular cases. One where this does end in 0, because if it does, then we don't even care about this this part here, right? If that has to be a 0, then this is not going to be 0. We're good. Plus the cases where this is a 2, a 4, a 6, or an 8, and this is not 0. Okay? And that's very similar to this one. So that's the problem with just finding the number of even 3-digit numbers, is because a 0 at the end of a 3-digit number makes it even. Okay, so if you have a 0 at the end, that means you'll have 9 possibilities here, not 8, right? Which we've been doing in the other one. So this would be equal to 0, there's 1 0. We've used it up, so we have 9 possible left, and then 8. So that's 72. Okay, and then this one, 4 possible even numbers that aren't 0. That can't be 0. So that's going to be, we've used 1 up, it can't have 0, so that's 8 there. We've used 2 up, so that's 8 there. So 64 times 4, remind me, is 256, right? Okay, and then we add those together. This 328. Okay, so that's the fast way. Total minus the odd. Although, saying that, you still have to calculate what the odd is. In this case, it was faster because we had already done the odd. But if you haven't, then it's kind of the same amount of work, right? 2 things to calculate. Okay. Last question. We'll get through a couple of them anyway. Okay, 10 different books comprising of 3 math books. So beware, there are 10 different books. The math books are different, but they're still math, right? chem books, 4 bio, and 1 physics. But they are different. We'll get to questions where maybe they're all the same textbook, right? But these are different. They just got the subject, math, or chemistry, etc. They're arranged on a bookshelf. How many arrangements are there if there are no restrictions? Well, we 10 different books, so that's going to be 10 factorial. Let's just leave it in factorial. Save a little bit of time. Oh, sorry. Okay, so the 2 chem books must be on either end, so this is going to be chem. All the other books, chem. And so there's 2 chem books, and then 8 factorial in between. Okay. Then, so there's 10 books, math books, there's 3 of them. So I'm going to do this. So, yeah, I'm going to do the 3 math books here. So this is kind of like the ones we were doing before. And then 1, 2, 3, 4, 5, 6, 7 other books. Okay, so the 3 math books, there's 3 factorial ways of arranging those. The way I've shown it here, this will be for starting with exactly 3 math books. So then here, that's going to be 7 factorial, the rest of them, right? So that would be the answer if we were starting with all 3 math books. This says they just must be kept together. So they could be there, or you could leave them in there, or in there as a group, in there, and there, and there, and there, right? So 8 places for that group of math books. So we're going to multiply by 8. So that means it's always going to be 1 more than the number of arrangements of remaining objects. So this is going to be 3 factorial times 8 factorial. You have to physically write it out where they're going to go with lines and count them up, then do it. But it's always going to be 1 more than the remaining objects. Okay, and then D, again, is the complement. So 2 chemistry books cannot be together. Well, we already calculated the 2 chem books are together. So this is the complement. So we'll go total minus chem together.
The figures that you're asking on your end.
Oh, yeah. Okay. Well, we'll still do that. Okay, so total is 10 factorial. Chem together, this was math together. So now chem together would be 2 factorial for the chem. There's 8 remaining books, and this is together anywhere. 1 more than 8 is 9, so that's 9 factorial. Okay. If you want to show it out, you can do, I'll do it down here. So chem together. There's your 8 remaining books. And then where can those be arranged? So they can be there or between 2, 3, 4, 5, 6, 7, 8, 9. Okay. You can figure out the value of that on your own. I'll leave that in a short time here. Okay? Then the next one, the books must be in the order of math, chem, bio, and then physics as seen from left to right. So math together, chem, bio, physics. Okay, in that order. So math, there was 3. So 3 factorial for the arrangements of the math. And chem, there was 2. bio, there's 4, and physics, there's 1. So you just multiply those together. Okay? Because it has to be in that order. Okay? How is that different from the last one?
Rearrange the units.
That's right. So here, these are in this particular order. The groups are still together, the types of books, but this is in the order math, chem, biophysics. This says that just the subjects must be together. So there's 4 ways of arranging. So it's now taking the subjects and arranging those. Right? Maybe it's chem, math, biophysics, or chem, math, physics, bio. So basically, these, so this is going to be 3 factorial, 2 factorial, 4 factorial. I'll show the 1 factorial, but that's just 1. Okay, and then taking those, so that's for each subject, and arranging the subjects, which is 4 factorial. Okay, so arranging math, chem, bio, and physics, those 4 is 4 factorial. And within each of those subjects is the 3 factorial, 2 factorial, 4 factorial. Okay, so I'll stop there. Try number 8 on your own, and then there's a lot of exercises. Obviously, if you're wanting to prepare for your unit quiz on Wednesday, save this till Wednesday night. Okay, there's a review posted in Schoology, and tomorrow is a review period. So, there you go.